Okay, so if you go for the first option, that means you need to perform the analysis twice, one with each gradient. The other option is you combine the two values into a single value. Okay, and this is what I will explain you today. And then obviously we'll move on to the complete analysis of level of service as well. How to combine two gradients. The method for combining two or more gradients in a segment is known as average gradient method. Okay, and according to average gradient method, the average gradient equals total difference in height divided by total length of the segment. So this is how you calculate average gradient. Okay. So as per the average gradient method, this is how you can calculate the average gradient. So if you have 2 or 3 or 4 gradients in a segment, you want to combine them, this is how you do it. Okay, and let us see how we can do it in an example. So we have a composite gradient profile. So composite gradient profile means a segment having multiple gradients. Okay, this is what we call as a composite gradient profile, a segment which has multiple gradients. So you can see here we have 2 gradients here. 3,000 feet of the length of the segment has 3% upward gradient, and 5,000 feet of the length of the gradient length of segment has 5% upward gradient. Okay, what gradient should be taken for calculating heavy vehicle equivalence, EHV? What gradient should we take? Okay, so we will apply the average gradient method, and we'll just see how. So first of all, tell me, I need to calculate the difference in elevation, right? How do I calculate the difference in elevation for this gradient? 3,000 feet length, 3% gradient. How do you calculate the difference in elevation or difference in height for this case? The length is given and the gradient is given. 3,000 into 3%. Yes, very good, Sam. This is what we are going to do. Okay, so average gradient. Okay, now I need the total. Okay, so if I do 3,000 into 0.03, this gives me difference in height for one gradient or due to one gradient. Then I add the other one as well, which is 5,000 length and 5% gradient, divided by the total length of the segment, which is 3,000, the first part for the first gradient, plus 5,000 for the second gradient. How much is this? Okay, fine. Give me the total, the gradient. $4.25, right? 4.25%. So if you need EHV, you will calculate it or you will get it from the table using 4.25% gradient instead of taking 3% once and then 5% in the second attempt. Okay, now in this question, it is not required to calculate FHV or find the value of EHV. But for the sake of explanation, so that you know how to use the table, I will show you how to get the value as well. Okay, first of all, you need to, now in this question, since it was not required to find out EHV or something like that, so obviously they did not give me percentage of trucks or heavy vehicles, and they did not tell me the type of mix as well. So I need to assume these two things, and I'm assuming just so that I can explain you how to get the factor from the table. Okay, don't ask me again at the time of exam, daughter, from where did you get 4% and from where did you assume this? I'm just assuming for the sake of explanation. Okay, it is not given because in the question they are not asking to calculate FHV. Okay, so let me assume that percentage of trucks and we have normal or what you call as standard mix. Standard mix means 30% single unit, sorry, 30% trailer trucks and 70% single unit truck. This is standard normal mix. Okay, so I'm assuming these two things.
Doctor, can you repeat what you said about the assuming part again?
In the question, they are not asking to calculate FHV. So they did not give me the percentage of trucks and what is the mix of the trucks. Okay.
Oh, so we're assuming.
But I want you to see how to get the value from the table. So I'm assuming these two things. Okay.
Okay, thank you.
Okay. Now, so for standard or normal mix, this is the table. Okay. First of all, look at the value of the gradient, which is 4.25. Now I have a value for 3.5 and I have a value for 4.5. So I will do some interpolation between them. Okay. Then second thing I need is the length of the gradient. The length of the gradient. So the length is given in feet, but for the table I need the length in miles. So let me calculate the length in miles. Total length 8,000 feet divided by 5280, which is the conversion for miles. How much is it? $1.5. Okay, this is again you can do some approximation, no problem. Okay, so length is 1.5 miles now. Okay, so you can see it's this range over here and this range over here. Remember, I'm interpolating between these two. So in this case, I will take a value from this row, and in this case, I will take a value from this row, and I have assumed 4% trucks. 4% trucks. So 4% means this column. Okay, so if you come to this column, for length of 1.5 miles, the factor is 5.27. And for 4.5% gradient, and the range obviously 1.5 is more than 1, right? So again, this row, and the factor is again 5.27. So I'm interpolating between 5.27 and 5.27. So no need for interpolation, right? Okay, so the problem is solved for interpolation. Okay, no need to do interpolation. Okay, because the values are the same. But if the values were different, you would have interpolated between them. Okay, and why I'm doing the interpolation? Because my gradient is 4.25%, and the table has values for 3.5 and 4.5. But in this case, the values are the same, so interpolation will still give me the same answer. So no need to do interpolation. You will take the value 5.27. So EHV will be 5.27 in this case. Okay. So let us move forward. There are a couple of actually 3 more examples here. I will not do all of them. I will just do the first one, and the remaining 2 are for your practice. Okay, so why I'm doing the first one? Because it has now 3 gradients. Okay, so the number of gradients can increase, no problem. Okay, you still use the same equation. So you have 2,000 feet with 3%, 1,000 feet with 2%, and 900 feet with 4%. So how to calculate the average gradient for this? Again, I need the total difference in elevation, total difference in height. Okay, so 2,000 into is 1,000 into %, 900. Okay, divided by the total length. Total length is 2,000 plus 1,000 plus 900. 2 plus 1 is 3 plus 900, so 3,900. How much is this? $2.97, or you can take 3% approximately, no problem. Okay, like I said, you can do some rounding off. Okay, so again, if somebody asks you to calculate EHV or to find out the value of EHV, then you will ask him about percentage of trucks and what type of mix he has. Okay, and then you will convert the length into miles, and then you go to the table and find out the value. Okay, like I did for the first case. Okay, moving on. Now we will do a couple of full examples in which we will calculate everything related to level of service. Okay, one for freeway, one for multi-highway, and then we stop there, inshallah. Okay, so this example is for a freeway. Okay, and this freeway has the following characteristics: 4 lanes, 2 lanes in each direction, 10 feet lane width, letter clearance on the roadside. Roadside, they mean the right hand side. By roadside, they mean the right hand side, because for freeways, I need the letter clearance on the right hand side, which is given 0 feet. Okay, 0 feet. Ramp density is required, it's given. Type of terrain, rolling, so it's one of the general terrain conditions. Trucks, typical mix, typical, normal, standard, they are synonyms here. Okay, they mean the same thing. 70% SUTs and 30% TTs. 70% single unit trucks, 30% trailer trucks. Okay, so means 2% with the normal mix. Peak hour factor is given. Current peak hour demand in the peak direction 3000 vehicles per hour. What is the level of service for this freeway? Okay. The first task is to calculate free flow speed. Whenever you are given with such examples, problems, the first thing you find out is free flow speed. Okay. Now, as I mentioned a number of times earlier, you can go and measure the free flow speed like you did for your term project, or you can use it calculating. You can use it using the equation. Obviously, this is a class problem, so I will not tell you to go and measure the free flow speed. You guys will not come back. I know that. Okay, so we will calculate it using the equation. So the equation is 75.4 FLW FLC to TRD to the power 0.84. Okay, so FLW, let me just do it over here. 75.4. Factor for lane width. Factor for lane width. Lane width is given as 10 feet. For 10 feet lane width, the factor is 6.6. Then factor for letter clearance. Letter clearance on the roadside is given as 0 feet. So this row, and I have 2 lanes in one direction. So the first column, factor is 3.6. Minus TRD, total ramp density is given as 5 per mile. 0.84 is the power. So tell me the free flow speed here. I take it 52.8. Okay. Okay. Second thing you find out is VP. Okay. The equation for VP is this: V divided by means to peak hour factor into FHV. Okay. So I need FHV. Number of lanes and peak hour factor is given in the question. I need FHV. So FHV equals 1 divided by 1 plus PHV. We used it yesterday as well. EHV minus 1. Okay. So percentage of heavy vehicles given as 2%. Okay. EHV for rolling terrain. Terrain is rolling, so I will find out the value of EHV for rolling terrain. For rolling terrain is 3. Okay. 3. So give me the value of FHV here. .962. Okay. Okay. Now we can calculate VP. Volume in one direction 3000. Number of lanes 2. Peak hour factor 0.95 and 0.9. How much is VP here? $16.42. Okay. Passenger cars per mile per lane. Okay. Now for calculating level of service, I need density. Density is flow upon speed. So flow is just calculated VP. Now you need to find out speed. Which may or may not be equal to free flow speed. So don't blindly take a speed as free flow speed and divide VP with it. Okay. For that we have a check. The speed of the highway can be either two of these values. It may be equal to free flow speed, or it may be calculated from this equation. How do I decide? I decide on the basis of value of breakpoint, BP. Okay, so now we need to calculate BP so that I know whether I should take it equal to free flow speed or I should use this equation to calculate it. Okay. Now, so if it is less than or equal to BP, the speed is free flow speed. If it is more than that, then the speed has to be calculated. Okay. Now, how to calculate BP? This is the equation for calculating BP of freeway. Okay. So you need the free flow speed and you need the capacity adjustment factors. Now, even with the free flow speed, you can see the subscript adjusted. Okay. So should we calculate adjustment factors here for speed and capacity? The answer is no. Why? In this example, no extra conditions are given. Okay, now remember, adjustment factors are for weather condition, driver population, work zone, and incidents. Did they mention any special thing about weather? No. So I will assume weather is as per base or ideal condition, no adjustment required. Did they mention any incident? No. So I will assume no incident happened on the highway. Did they mention any work zone? No. So I will assume there is no work zone on the highway. Did they mention anything about driver population? No. So I will assume all drivers are familiar. Okay. So if adjustment factors are required, then it will be mentioned with the question that you need to calculate adjustment factor for this condition. Okay. So either they will mention something about weather or driver population or work zone or incident. In that case, you may have to calculate adjusted free flow speed, and you may have to calculate CF, capacity adjustment factors as well. Okay, but in this case, nothing is mentioned, so free flow speed will be used here in this equation directly without any adjustment, and CF will become 1. Okay, I mentioned it earlier as well. Whenever you are not applying any adjustment, the factor becomes 1. Don't make it 0. If you make it 0, this whole equation will become 0. Okay, so we will not make it 0. Okay, we take it 1. So CF becomes 1 and free flow adjusted is equal to the free flow speed which you have just calculated. Okay, so let us calculate BP here. BP equals 1000 plus 40 into free flow speed, which is 52.8. 25 minus. Okay, how much is BP? $18.88. Okay, fine. Passenger cars per hour per lane. Okay. Now this value is more than VP. Okay, so when it is more than VP, I'm in the first condition. So whatever free flow speed you have calculated, you can keep it, you can assume that speed is equal to that value, or speed is equal to that value. Okay, so S is equal to free flow speed 52.8 miles per hour. Then density equals VP upon S. So that is 1642 divided by 52.8. How much is this? $31.1. And the units will be passenger cars per mile per lane. Okay. Now, if you know the density, then we have a table which gives level of service according to the range of density. This is a table. I'm looking for a freeway. Level of service for a freeway. So 31.1 means you are in this range. So level of service is D. Okay. In this example, first of all, I found the value of free flow speed. Then I found FHV, calculated VP, and then I compared it with breakpoint. And then I found, or I fixed the value of speed, and then I found density. And on the basis of density, you can know level of service. So this was for a freeway. Now we'll move on to multi-lane highway as well. There are some notes written in the slide. Okay, I forgot to mention them to the other section as well. You can go through it. But what they are saying is level of service D is mainly because the cross-section geometry is not sufficient. The lane width is very low. 10 feet is a very low value for freeways, and there's no lateral clearance, 0 feet lateral clearance. So that's why you are having level of service D. Otherwise, 3,000 vehicles per hour for a freeway is not a large value of flow. Okay. Now moving on to multi-lane highways. 4-lane multi-lane highway with a full median, peak hour volume 2600 in the heaviest direction, 12 feet lane. So you can see here in this example as well as the previous example, the values that were given or that were used were all for one direction at a time. You are doing everything for one direction at a time, and this is what you have to do for your term project as well. You calculate level of service for each direction separately. Okay. And you will follow the same procedure, except the free flow speed is not to be calculated. It will be the mean speed from the spot speed data of second submission. Okay, this multi-lane highway has 12 feet lanes, 4 feet clearance at the roadside and in the median. Okay, so median side means the left hand side and roadside means the right hand side. So 4 feet on each side, so total is 8 feet. 10 access points per mile, 10% trucks with a standard mix. Standard mix meaning 70% SUTs, 30% TTs. Okay, and you call it a standard, you call it normal, you call it default, means the same thing. Okay, something which is normal, something which is normal. Okay, peak hour factor is given. Now this segment has a sustained gradient of 3.5% at a length of 1.25 miles. Okay, base free flow speed is given because it will be required for multi-lane highway calculation of free flow speed. What is the level of service expected on upward and downward gradient? Okay, now understand one point here. You can see only one gradient is given and only one volume is given as well. I forgot to mention one point from the composite gradient case as well. So let me explain that and then I will come back to this example. So when we are calculating average gradient, you can see I took all values as positive, right? In this case, as well as the previous example case, I took this case as well as this example, I took all values as positive. So in the composite gradient profile, in the first example, with every gradient, it was mentioned that it is upward. In the second example, it was not mentioned, so I just assumed that it was upward. But what will happen if a gradient is downward? What will happen to the average gradient then? If a gradient is downward, then you will put it with a negative sign in the average gradient equation. Okay, so for example, if this 2% was a negative gradient, a downward gradient, negative means downward. Okay, so if you have a downward gradient, then this 2% will come with a negative sign here. Okay, so this 2% will come in a negative sign here. Okay, so keep it in mind. So wherever you have a downward gradient, in the average gradient equation, it will go with a negative sign. Okay, coming back to this is something I forgot earlier. Sorry for that. Now coming back to this example, you can see that they have given me one volume and they have given me one gradient. And they are saying this gradient is both upward and negative and downward both. How is that possible? This is for each direction. Okay. So if I am going from the right hand side of the road, if I'm going in one direction from A to B, for example, I may be going upward. But when I come back from B to A, then I will be moving downward on the same road. So the same road can have two gradients in different directions, not two values. I mean two signs of the gradient. Okay, two different signs of the gradient in two different directions. So if one direction is upward gradient, the other one will obviously have a downward gradient for the driver. We are talking about the perspective of the driver. So if for the gradient for one direction of drivers is upward, then for the other direction of drivers it will be downward. Okay. Now you may argue, so upward and downward, one highway can have both, and we can analyze both. So when we say upward and downward, basically we are what we are doing, we are analyzing for the upward and downward, meaning one direction and the other direction. Okay. Now you may argue, then why they have given me one volume? This volume is only for one direction, see, in the heaviest direction. Why didn't they give me two volumes then? They should have given me volume for each direction separately. The answer to that is normally during the course of the day, volumes repeat themselves in different directions approximately. So for example, from A to B in the morning, 2600 people are going from one direction. Then in the evening, approximately same number of vehicles will be coming back, approximately. Okay, so that's why even if you have a volume of one direction, you can assume that it will be the same in the other direction, and you can use it to analyze the other direction as well with a change of gradient if it is required. Okay. So now let us move on. Again, we start with the calculation of free flow speed. It is not given and you cannot measure it, so we'll calculate it. For multi-lane highways, the free flow speed is calculated as this: base free flow speed minus FLW minus FLC. Okay, base free flow speed is given in the question, 65. Factor for lane width, I have 12 feet lanes. Factor for lane width, 0. For 12 feet lanes, factor for lane width is 0. So 0. Then factor for lateral clearance. I have a 4-lane highway. So these two columns. And I have 4 feet lateral clearance on each side. So 4 plus 4, total is 8. So 8 here. Okay. And then the factor will be 0.9. So 0.9. Okay. Then factor for median type. I have a full median. Full median means it's a divided highway. The factor is 0. Then factor for access points. I have 10 access points per mile. So this one, the factor is 2.5. How much is this? $61.6. Okay. So again, I need to calculate VP, and for VP, I have to calculate the value of FHV. For FHV, I need EHV. Now the EHV will change because of the gradient. There will be two values of EHV, one for upward, one for downward. Okay. So EHV for upward. Okay. The standard mix, right? I'll use this table. Okay, so the mix is not mentioned, that is for standard mix. Okay, so the gradient is 3.5%. The length is 1.25 miles. Okay, and the percentage of trucks is 10%. Okay, so you come here, the factor is 2.96. You cannot see it clearly here, but it is, the table is more clearer. The table is clearer in the book. Okay, for the time being, just believe me, this is 2.96. Okay. How did I get it? The value of gradient, 3.5%. Okay, so these values are upward. All these values are upward. 3.5%. length is 1.25 miles, and 10% trucks is this one. So factor is 2.96. 2.96. Okay. Then EHV for downward. Now you can see all downward values are here in the first row. Gradient 0 or less. So downward is negative, right? So less than 0. So whatever downward gradient you have, we just take the value from the first row. Okay. So this row length doesn't matter, and 10% trucks. So 1.96 is the factor. 1.96. Okay. So now we can calculate FHV. Percentage of flux 10%. For upward, factor is 2.96 minus 1. Okay. And same thing for downward as well. I just change the value of the factor and that's it. So give me both the values for FHV. 836 and 912. Okay, fine. 836 912. Okay, now I can calculate VP for upward and downward. Volume 2600 divided by number of lanes 2 in each direction. Peak hour factor 0.88. And the factor for upward 1767. Okay. Passenger cars per hour per lane. Second one. $1,620. Okay, then I need to check it with BP. Okay. Now the good thing about multi-lane highways is the value of BP is fixed. Okay. There's no equation to calculate BP for multi-lane highways. The value is fixed at 1400. Okay, BP for multi-lane highways is always 1400. Okay, so BP is 1400 passenger cars per hour per lane. Now this is less than VP of both directions, right? So for both directions, I have to calculate the value of S. I cannot assume that S equals to free flow speed, because in both directions BP is less than VP. So I'm in this condition for both directions. Okay. Now, so this is the equation which we are going to use, and again, no adjustment conditions are mentioned. So I will just assume that whatever FFS I calculated is the FFS adjusted, and sorry, it is a multi-lane highway, so no adjustment is required. It is a multi-lane highway. For multi-lane highways, we never do the adjustments. For multi-lane highways, we never do the adjustments. So FFS is whatever you got. FFS adjusted is FFS you got. That's it for multi-lane highways. Okay, but in this equation you can see that I need capacity as well. So for multi-lane highways, the capacity equals to this. This is the equation for capacity. Okay, so I need to calculate capacity, which is 1900 plus 20 times free flow speed, which is 61.6 minus, how much is the capacity here? $2,232 per hour per lane. Okay. Now once you calculate it, there's a check as well that this value should be less than or equal to 2300, which it is. So I don't have to worry about it. I can move on to the rest of the calculations. So speed equation is this. Okay, so S equals free flow speed 61.6 minus free flow speed again 61.6 minus capacity 2232 divided by the density at capacity. Density at capacity, I have mentioned earlier, is fixed at 45. So DC is 45 for all cases. Okay, DC is 45. So divide by 45. BP minus BP. BP is, now I'm doing it for upward. Okay, so I'll use a BP of upward 1767 minus BP, which is 1400. Okay, to the power A. Okay, A is again fixed for Mundane highways 1.31. Mundane highways A is 1.31. So 1.31, bracket close, divide, put another bracket. Capacity 2232 minus 1400. The power 1.31, bracket close. Okay. Yes, if it is not less than 2300, you will use 2300. Okay, if the capacity is not less than 2300 for multi-lane highways, you will use 2300 as capacity. So C will become capacity if the calculated value is more than 2300. Okay, so the speed for upward direction or with upward gradient, and then for the downward gradient as well. The only thing which will change is BP. $57.5. Okay, what downward? $59.5. Okay, then you will calculate density for upward and downward conditions. Density is flow upon speed. Flow for upward is 1767 divided by speed, which is 57.5. Okay, and then you will do the same thing for the downward condition as well. $30.7, okay, and 27.23. Okay, both are passenger cars per mile per lane. Okay, so if you go to the density table, okay, multi-lane highways, this, okay, you got the values as 30 and 27. So 30 and 27 both are in this range. So in both directions, the level of service is D. Okay, it can change. It can change, but in your case, if your calculations are correct, the level of service is the same. Okay, but keep in mind it is not fixed. Okay, you can have two different levels of service in some other example in both directions. Okay, now we have another example. I could not start it in the other section, so we'll not start it. Sorry, I started it, but I did not do much in it. So we'll just calculate the level of service. Sorry, we will just calculate the, you know, Yeah, this one. Okay, so we just calculated the free flow speed for this example. Okay, so this is what we will do, and then we will do the remaining part of the example on tomorrow, inshallah. Okay, so it's a new freeway now, a new freeway which is to be designed, and the design volume is 2700 vehicles per hour in one direction in the peak hour. The prevailing conditions on the freeway are expected to be these, that it will have a peak hour factor of 0.85. The users of the facility will be familiar, 15% trucks, and it will have a heavy mix. So you can see the meaning of heavy mix here as well. 30% single unit trucks, 70% trailer trucks. TRD is given. A long segment of the facility has a level terrain, but a 2-mile segment has a 4.5% gradient as well. So two different conditions are mixed in this example. Two different terrain conditions are mixed in this example. If the objective is to provide level of service C, then how many lanes should be provided? And level of service D is also acceptable. Okay, it's a very long example. It will require a lot of work. So we will do most of the work tomorrow. But today we can at least calculate free flow speed. Okay. Now, for design example, you always need to calculate the free flow speed because the freeway is not operational. So how can you measure it? Okay. So for the freeway, the free flow speed equation is this. Now I need FLW, I need FLC, and I need TRD. Okay. Now if you go back to the question, TRD is mentioned, so no problem. TRD is 0.5. Lane width and letter clearance is not mentioned. Lane width and letter clearance is not mentioned. Now, for this example, since it's a design problem, I can even work without them giving me the values. Even if they don't give me the values, since it's a design problem, I can even work without that. Why? Whenever you are designing, you design using standard values. You design using standard values. Unless the client says that you cannot use a standard value. Okay. In this case, the client is not telling me anything. There's no restriction from the client, right? So I will assume that I have taken the standard value of lane width and I will provide a standard value of letter clearance. In that case, you don't need these factors. Okay. So both these factors will become 0. So it will be 75.4 minus 0 if you take the standard value of lane width, and minus 0 again if you take the standard value of letter clearance. Okay, and TRD is already given. So how much is the free flow speed here? $73.6. Okay, so what did I do different here? It was a design problem, and lane width and letter clearance was not given by the client or by the engineer, whoever was in charge. Okay, so I assume that whenever they will design it, whenever they will construct it, they will construct it using the standard values of the widths. So in that case, you take the factors as 0. Okay. So this was a special case for the design part and without the data. Okay, so we will continue with this example inshallah tomorrow. Okay, so again, you are free slightly earlier today as well, which is good for you, good for me as well. Any questions, any clarifications? Everything is correct? Everything is fine? Okay, so see you guys tomorrow inshallah. Have a nice evening and masala.